today we're going to connect expanding this and that whole combination thing where it's 3 choose 2, right? So again, just saying it, not super important that we write this next part down, but I am because I was a teacher. All right, so, well, what am I going to do? Well, I want to talk about how you expand this, and we know how to expand this. Like, we know that this is x plus y times x plus y times x plus y, right? That's what we know. And what I'm going to do is I'm going to multiply this out in a non-traditional way, right? And we could just sort of explain it as, I'm crazy, right? Math teacher's crazy. And how this works is we're going to multiply these together, and I'm going to say x times x is xx. X times y is xy. And then y times x is plus yx, and then y times y is plus yy. All right? Did everybody see the pattern I was using? It's not important to write it down, but you see the pattern. The pattern's actually kind of important. And again, no sane person would ever multiply it out this way. All right, now we're left with, I've got to multiply this x plus y times all of this. So now when I multiply it, I end up with this times this is going to give me, I'm going to start over here, x. This times this is going to give me plus xy. This times this is going to give me plus xyx. And this times this is going to give me plus xyy. So far, so good. Now, here's the interesting part, right? First, do you notice what I have up here? Oh, wait, I'm not done yet. I got to finish them a long way down. Got to multiply this times this. I get plus yxx plus yxy plus yyx plus yy. And maybe in 7th period I will start further to the left because it goes a long way. But what I want everybody to notice about all this, do you notice that each one of these terms has 3 letters? Does everybody see that? And these 3 letters are just sort of a combination of x and y. Notice I use the word combination, right? Now, so we have all the possible combinations of x's and y's, right? So let's sort of write down what we have. And what I'm interested in is, are there any terms that only have x's? How many terms only have x's? Does everybody see this is the only one that has x's? And so we're going to simplify this, and I'm going to say that this is x cubed, because that's normally that's how sane people write that. And the next thing I've got is, the next thing I have is I've got 2 x's and 1 y, so that's going to give us x squared y. And sort of my next term is going to be 1x and 2 y's, and then my last term is going to be all 3 y's. Like if you were to multiply this out, right? Like if you were to sort of not multiply it out this way, but just sort of combine them normally, you would have ended up with an x cubed, a something x squared y, a something xy squared, a something y cubed. Now let's talk about those somethings. I'll answer your question in just a second. Right? So when we're looking at this, does everybody see there's only one that only has 3 x's? How many of these terms have 2 x's and 1 y? Now let's see, that has 2 x's and 1 y, that has 2 x's and 1 y, and that has 2 x's and 1 y. Are those the only ones that have 2 x's and 1 y? And so how many is that? 3. And so that's going to give me a plus 3x squared y. Also, you can kind of look at it. Notice how I've written it. See where look at the single y term. See how the single y term was at the right, then it's in the middle, then it's at the left. It's sort of moving around. We'll talk about that in just a second. How many terms have 1x and 2 y's? Let's see. There's 1x and 2 y's. There's 1x and 2 y's and 1x and 2 y's. And if you look at the x, then notice how that x goes in the different spots. Like the x is in the first, x is in the middle, x is in the last. And so how many ways was that? 3. And then, of course, how many terms just have 3 y's? The 1. And so we end up with, if I were to multiply this out like a sane person, my final answer would be x cubed plus 3x squared y plus 3xy squared plus y cubed, right? So this is the answer, right? But here's the cool part, right? Notice how all of these have 3 positions, right? And what we're going to do is we're going to count the y's, right? The way I want you to think of this number is we have 3 positions. I want no y's, and so this is going to be 3, choose 0. I have 3 spots. I want to choose no y's. This is, I have 3 spots. How many y's am I interested in?
0.
No, in this term. How many y's? I have 3 spots. How many y's do I want? How many spots have to have a y? 1. And so this is, I have 3 positions. I want to choose one of them to be a y. And this is, I have 3 positions. How many of them do I want to be y's? 2. So this is 3, choose 2. And then this is, I have 3 positions. How many of them do I want to be y's? 3. I want 3, choose 3. And just for laughs and giggles, right? Are we okay that 3, choose 0 is equal to 1? If you were to type that in your calculator? Or you can actually think about it. If you have 3 people, how many ways can you choose how many ways can you choose none of them? Well, there's only one way, right? You can think of this as 3, choose 1. I mean, you could work it out. 3, choose 1, that's equal to 3 factorial over 1 factorial, 2 factorial. And if you work that out, you get 3. But the thinking way about it is, okay, you got a group of 3 people. You 3. How many ways could I pick one of you? I could pick you, I could pick you, or I could pick you. Those are the 3 ways. And then as far as 3, choose 2, we just work it out. So did this kind of make sense? Do you see how this choosing, this combination, helps us figure out that coefficient, right? So what, right? I just did a really, really long explanation of something that would have been probably easier just to multiply it out by hand. But my goal wasn't to figure out what x plus y cubed is. My goal is, and now you're going to write this down. I'm just sort of preparing you. Everybody needs to write this down. It's kind of important. I need to make sure I get as much board space as I possibly can, because I'm interested in x plus y to the 5th. Everybody written down x plus y to the 5th. And so if I want to find out x plus y to the 5th, well, the first thing so the official title of this is we're expanding a binomial. This is a binomial, and we're going to raise it to different powers, and we have to expand it. I have to multiply it out. So one option to multiply this out is literally write it out 5 times and start multiplying. And I'll come back in about 30 minutes, and you'll be mad at me, and then I'll come back in again another 15 minutes, and you'll still be mad at me. And maybe after a little while, we'll have the answer. So we need a better way, right? So let's think about what my final answer looks like. If I'm multiplying it out 5 times, right, if this time's 5 times, does it make sense that we're going to have an x to the 5th term? Like, remember this, if I had x plus y cubed, I had an x cubed term. And then how you figure out the terms, like the subsequent terms, is you need to think that, well, x is going to be 3, then 2, then 1, then none. Like the x's go down, and then the y's go up. And so what we end up with is, I'm going to end up with an x to the 5th term. Everybody write that down. Put a plus sign. And now, the x's are going to go down, and so if this is x to the 5th, my next term is going to be an x to the 4th, and this is, you start counting the y's, like this term has no y's, this term has 1 y, and the next term has 2 y's. And so this is going to give me x to the 4th y. What's going to go here? X to the 3rd, y to the 2nd. Does that make sense? Everybody see what's going on? What goes here?
X squared, y cubed.
X squared, y cubed. what goes here?
X, Y to the fourth.
X, y to the fourth, and then I get a y to the fifth. Okay, now, just to make sure everybody understands the pattern, do you see the x's are going down? 5, 4, 3, 2, 1, and none? Does everybody see that the y's are going up? 1, 0, 1, 2, 3, 4, 5? And the sort of the check at the end is make sure that when you add the exponents, you get this. 5 and 0 is 5, 4 and 1 is 5, 3 and 2 is 5, 2 and 3 is 5. Everybody see how if you add the exponents, you get whatever this is. So far this isn't bad, is it? As far as expanding to the fifth. We're missing these numbers. All right? So how do you find the numbers? Well, don't worry, I'm going to show another way in a little bit, but how we're going to find the numbers now is that whole combination thing. And that whole combination thing is we have 5 positions. We're going to choose none of them to be y's because we're counting y's. What's this one going to be?
What does it say, 5 over 0?
5, choose 0. Okay? What's this one? If you're counting y's, what's this one going to be? 5, choose 1. Perfect. What's this one going to be? 5, choose 2, because we're counting our y's. And so this is going to be 5, choose 2. Everybody see what's going on here? Plus 5, choose 3. Plus 5, choose 4. Plus 5, choose 5. Was everybody okay with that? Everybody see where I got those numbers? So, compute them. Get a calculator out. Y'all know how to do this. It's the C button. Because I want to know those numbers. Well, I already know this is 1, because if you have a group of 5 people, there's only one way to choose none of them. And guess what? This one's got to be.
5.
It's got to be 5. Because if you have 5 people, how many ways can you choose 1? Well, there's 5 different people, so you can choose 5. What's 5 choose 2? 10. What's 5 choose 3? 10. What's 5 choose 4? 5. And then 5 choose 5, that's 1. If you've got a group of 5 people, there's only one way to pick everybody. I mean, so technically our answer is going to be x to the 5th plus 5x to the 4th y plus 10x cubed y squared plus 10x squared y cubed plus 5x y to the 4th plus y to the 5th. Does that make sense? And my claim is doing this is a heck of a lot easier than actually multiplying it out 5 times. All right, so let's just sort of recap what we did before I make things a little harder. All right? Whenever you're expanding a binomial, the first thing you care about are these little terms, right? You care about the x's and y's. And you want to make sure you get that. That's what you always do first. So you think, okay, this is x, x to the 4th y, x cubed, y cubed. Make sure the x's are going down, the y's are going up, and these exponents, when you add them together, give you 5. And then you need to worry about these numbers, right? They've got coefficients, and how you got that whole combination thing, and so that's 5 choose 0, 5 choose 1, 5 choose 2, right? But you need a better way, right? Because this is a little tedious, isn't it? I mean, you could do this. I mean, you don't need a calculator for these. You could do these by hand, right? Actually, do y'all see it's symmetric? Did y'all notice that? Like the numbers on the left are the same as the numbers on the right? Here's why, right? I want to make sure you understand why. I'm interested in about this thing, 5 choose 2. All right? And here. The best way I can describe that, so I don't know if you noticed, but 5 choose 2 and 5 choose 3 are the same number. Well, if I have 5 dots, 1, 2, 3, 4, 5, right? And 5 choose 2 is how many ways I can pick 2 of them. So think about these are 5 members of your class. And so how many ways can I pick 2 of them, right? So let's say I'm going to pick these 2, right? And so how many ways can I pick 2? It's, well, obviously 10. But I guess you could look at it the other way. If I pick a group of 2, do you see how I've made 2 groups? I've picked a group of 2. How many are left? 3. If I pick a group of 2, I've got a group of 3. So do you see that 5 picking a group of 3 is the exact, you're still separating the students the exact same way, you're just calling it differently. So one thing nice about this whole thing is that you got this nice symmetry. All right, so there was a mathematician, his name was Pascal. He was a bit of a gambler, right? And he gets credit for what I'm about to do, even though there's some guy in China that came up with it, I think 800 years before he did. And China gets left out of a lot of stuff, and it's not my fault. It's just, if you just happen to live in Europe, you get more advertising than someone that lived in China. That's just kind of the way it worked. And what he was doing is he kind of wanted, because he gambled, it's important to count, come up with a sort of a efficient way of counting. And here's what he noticed. And I'm going to explain this. I was going to explain it Monday, but since a lot of you are going to be out, because the explanation part I think is kind of neat, I may do that part Tuesday. And what he did is he wrote, let's see, he started off and he said 0, choose 0, and this is like the zeroth row, and then he did 1, choose 0, 1, choose 1, 2, choose 0, 2, choose 1, 2, choose 2, 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3, 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, and 4, choose 4. All right? Here's what he noticed. Now, I don't have time to explain this now, but I will Monday or Tuesday of next week, whenever y'all aren't taking an AP exam. And what he noticed, and actually we can mathematically prove, first, y'all recognize that each one of these is a number, right? Like you could type this in. Like this is actually the number 1. All 3 of these things are 1. This is a 1, this is a 2, this is a 1, right? All of these do create numbers. And what he found was that this plus this gives us this number. This plus this gives you this number, this plus this gives you this number, this plus this gives you this number, and this plus this gives you this number. Right? There's a mathematical explanation, and I'll explain it. Just not today, because there's other stuff I've got to do. Right? And he gets credit for this, and they call it Pascal's triangle. Right? Remember, although some guy in China did it long before he did. So what we're going to do is we're not going to create this version of Pascal's triangle. We're going to create the version that's actually helpful for you. Right? And so I want everybody to start. We're going to make this. Right? So when we make Pascal's triangle, we start with a 1. So everybody start with a 1. So I'm going to call this the zeroth row, right? And then the next row, every row starts with a 1 and it ends with a 1. So there's a 1, there's a 1, and a 1. Is everybody writing this down? And then there's this row that starts with a 1, and how you get this term is you add these together. So what do I get? 2. And then you end with a 1. Right? And then we're going to start here, and well, it starts with a 1. And if I add these together, what do I get? 3. Then I add these together, what do I get? 3, and we end with it. Does everybody see what's going on? I think you're writing this out, good. All right, so now see what happens here. We start with a 1, what's here? 4. What's here? 6. What's here? 4. And we end with a 1. All right, then let's start here.
1.
1. Is everybody writing this down? Okay. Okay. What's this?
5.
5. Thank you. 10. 10. 5. 1. Okay. And let's see. So then we're going to get a 1, a 6, a 15, a 20, a 15, and a 6, and a 1. All right. Has everybody got this so far? And so I want everyone to do the next two rows. I want everybody to write down the next two rows. And after you do the next two rows, you'll see why I didn't ask you to do the third row. Was everybody got it? All right, so I'm going to create the next two rows. So oops, I need to move the camera over. It's like you need a lot of board space to do this. You just can't work it a little bit. So this starts off, this gives us 1, 7, 21, 35, 35, 21, 7, 1. And then the next one's going to give us 1, 8, 28, 56, 70, 56, 28, 8, and 1. It looks more intimidating, but I mean, notice it's symmetric, like the first half. Once you get the first half, you know the rest. Do you see why I stopped here? Because if you go to the next row, you're going to have numbers over 100, right? These numbers get pretty big very quickly, right? And so this is Pascal's triangle. It's got all these counting arguments in there, right? And Pascal liked gambling. He did this. Now, there are tons and tons of patterns in Pascal's triangle. I will talk about those next week when most of you are here, right? What I need to talk about today is one pattern. And believe it or not, this one little triangle, this pattern, helps us expand binomials. So let's see. So I'm interested in x plus y to the 0. What's anything to the 0 power? 1. Okay. Yay, right? And if I do x plus y to the first, we get an x plus y, no big deal, right? Nothing's fancy going on here. But if I deal with x plus y squared, right? What's x plus y squared? No. Bad. Not good. Not as bad as that, but not good. It ends up being x squared plus 2xy plus y squared. Huh. Do you remember we had x plus y, we did x plus y cubed at the beginning of class? Do you remember what this one was?
X cubed.
3x squared y plus 3xy squared plus y cubed. Do you remember that? Huh. Why am I doing that? Well, do you notice Pascal's triangle are the coefficients of these things? See, there's a 1 and a 1. That's the 1 and the 1. The 1, 2, 1. 1, 2, 1. This is 1, 3, 3, 1. 1, 3, 3, 1. Y'all see it? There. Let's see if we can figure out what's happening. And so they call this the zeroth row because you were thinking about raising something to 0. This is the first row, second row, third row, fourth row. Let's see if we can use Pascal's triangle to help us figure out what x plus y to the fourth is. All right? So, if it's x plus y to the fourth, what are the letters? Okay. So we're going to worry about the letters first. So I've got x to the fourth. What's the next term going to be?
X
X cubed y.
X cubed y. X squared y squared. Xy cubed. And then y to the fourth. Does everybody see that? And I'm going to put a plus next to all this. So guess what numbers go here? 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Yes.
Why did the middle one get? No. Okay.
Does that make sense? Are you starting to see how we can use Pascal's triangle to help us expand a binomial? Now, just to be completely transparent, expanding a binomial is always a pain. I never said I was going to make it instant, all right? But expanding a binomial this way is significantly faster than having to multiply it out 4 times. Everybody kind of agree with that? And the focus of today is expanding binomials of various degrees of difficulty. Right? I'll talk about Pascal's triangle later, right? I'm just using Pascal's triangle to help us expand. Everybody got? So does everybody have Pascal's triangle written down somewhere? Because I need the board space.
Is it Pascal or Pascal?
Oh. Pascal. Blaise Pascal. There was a math professor at North Georgia, Jimmy Woods, who was probably one of the best, was probably one of the most entertaining professors I ever had. I didn't go to North Georgia. He came to UGA to give a couple of lectures. And he was a big Pascal fan. He has 2 sons. One of them's named Blaise and the other's named Pascal. Not kidding. Okay. So, Pascal died young. I think he died when he was 41. He was a prodigy. Like he did, and he wasn't. And he was pretty proud of the fact that of the stuff that he did when he was younger. I mean, he used to. He was sort of quoted, "Yes, I learned this when I was 12." It's like, good, nice job, guy. You know, not too many people care. I mean, you did some other stuff, but you know. All right. So, what are we doing? I'm flipping over my pages to find out the examples. All right. So, I would like to. So, how do you expand something like x plus? I'll have to, hoping I have enough time. Oh, no, I do, because this class ends at 12:30. Okay. I have 2 examples. This is one example, then we'll do the hard one. So this is the easier one, then we'll do the harder one. And what I want you to think of is this is the first part, this is the second part. And so has everybody written this down? And here's what I need everybody to do. Right? And it's going to seem like an absolute pain and you're wasting time and everything else. You're not wasting time. I'm just sort of speaking from experience. Students that don't do what we're about to do don't get the problem right. Right? It's too easy to make a mistake. There's a lot of stuff going on. So, step 1. Do you see I have 2 things raised to the 4th power? And so what I want you to do is, okay, we got 1 thing to the 4th, and then we'll have, this is to the 4th, this is to the 3rd, that's to the 1st. Then I get something squared, something to the 1st, something cubed, and then something to the 4th. You have 2 somethings. Right? You don't have to do the parentheses when, like for future, but this is what I do. Right? I'm trying to train you how I look at something. All right? What's our first thing? X. And so I know an X is going to go here, 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 and here. What's our second thing? Everybody see that our second thing's a negative 3? And if our second thing's a negative 3, that means a negative 3 goes here, 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 and here. Is everybody with me so far? Now, I need the numbers, right? I need those numbers from Pascal's triangle. So you've got Pascal's triangle. What goes here? 1, 4, 6, 4, and a 1, right? Is everybody okay? Yes.
Why is there no close above 4?
Oh.
Oh,
Yeah.
okay.
And I hesitate putting the pluses in, and you'll see why in just a minute. This is not your final answer, right? We have to clean all this up. So pick up my black pen, and we're going to write the final answer. All right, are we okay? The first term is going to be x to the 4th. That's pretty easy, right? So we're going to get x to the 4th. All right. Are we okay that the second term has an x cubed with it, right? What's the number that goes in front? Is everybody okay? We get a negative 12 out of that? So we get a negative 12. All right. Are we okay that this gives us an x squared? What's the number that goes in front?
No, 54.
Negative 50,
No,
54.
positive 54, right? Negative, see that negative 3 squared is a 9 and a 6. 6 times 9 is 54.
Yeah.
And it's positive. Okay. Now let's look over here. Well, the x term is just an x. Let's see. 3 cubed is negative 27, right? And I have to multiply it times 4, right? So when I get 4 times 27, that's 108, and it's minus, so I get negative 108. And then our last term, well, negative 3 to the 4th ends up being 81, so I end up with 81. And
How'd you know to start with the 1, the 4, the 6? How'd you know which numbers to start with on the triangle? Like, how'd you know it was 1, 4, 6, 4, and 1?
So a couple of reasons, right? This is the only row that fits. If you pick any other row, you're not going to have enough numbers. You're going to have too many numbers.
Okay.
All right. Second reason, the 4th row. So when you're looking at this, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Whatever the second number is, that's the row you're on. And since that's raised to the 4th, you want to go to that.
Oh, okay.
Okay? But a sort of a check is you don't have enough numbers. Either you don't have the right amount of numbers if you pick the wrong row. Does that make sense? Is everybody okay with this? All right. Good. I have enough time to do one more example and give you a hint of the patterns that exist in Pascal's triangle. Not all, just a hint. There's a ton. I mean, literally, I need to work up a lesson where I just talk about the magic of Pascal's triangle.
Wait, Mr. Elvis, I kind of made a mistake, so I went back to fix it, and I missed what you did. So after we got the coefficients 1, 4, 6, 4, 1, how did we get the bigger numbers? Or did we just...
Look at the video when I post it. I can't put all that back on.
Okay.
Okay. All right. So now, let's look at, I'm going to start way over here. I want to do x cubed minus 2y, and all of this is raised to the 5th. So everybody got that? All right. All right. So we have two terms, right? Step one, I want you to think of this as, okay, we're going to write down this thing, and then the next term was going to have two things, then two things, two things. I ran out of room again. I need to do a better job of thinking about what the board space is. 5, 4, 3, 2, 1, and none. Okay, good. That's all right. One thing, two thing, right? Part 1 and part 2, right? First part, second part. Now, let's do exponents. What's this exponent going to be? 5. And then what are these exponents? 4 and 1. What are these exponents? 3 and 2. 2 and 3. 1 and 4. And a 5. Did that make sense? Was that step easy? Believe it or not, doing this step makes the problem a whole lot easier. Thinking that you can do this without thinking, just without, if you think you're going to skip this step, you tend to make a mistake. All right, so first, what goes here? What's your first part? X cubed. All right, so if this is your first part, that means this is going to go in all of my first parts. So there's an x cubed here, an x cubed here, an x cubed here, and an x cubed here. What's your second part? Negative 2y. So I get a negative 2y, negative 2y, negative 2y, negative 2y, negative 2y. Have I lost anybody?
No.
Okay, as silly as it sounds, doing this sort of guarantees you get the right answer. We're missing something. What are we missing? Those coefficients, right? Well, good thing we have Pascal's triangle out, right? What are the numbers? 1.
5, 10,
And then it repeats.
5, 1.
Everybody okay? And now we get to do our, yes,
How would we know the coefficients if we didn't have triangle?
make the triangle.
Oh, God.
So I went over how to teach how to do it. How hard was it to make the triangle?
Is this time consuming?
Like that.
No, it's not.
I thought that was.
That's way faster than computing 5 choose 0, 5 choose 1, 5 choose 2.
That's true.
Okay.
But it did take a while.
Yeah, all right. All right. So now let's write our final answer. What's this going to be? X to the what?
15.
X to the 15.
Sorry, one more thing. Why, so why didn't you put the plus?
Oh, you'll see why in just a second.
Okay.
All right. So are we okay that the first term is x to the 15? Now, when dealing with the second term, what you want to do is deal with the letters first. What are the letters going to be? X to the what, y to the what? X to the 12th, y to the 1st. Everybody see that's our letters, right? Now we need to think of the number, right? And if you look, see how I have a 5 and a negative 2. What's going to go here? Negative 10, so a minus 10. Do you see why I didn't put the plus? Because I knew there was going to be a minus here.
How did you get the minus thing again?
Because there's a negative 2 here.
Oh,
So the negative 2 times 5 gives you negative 10.
maybe 2 times 5, yeah.
Okay? All right? So now let's go here. What are the letters? X to the 9th, y squared. Is everybody okay? Those are the letters? Yeah, x to the 9th, y squared. All right? Now let's think of the numbers. So the only two numbers I have are here and here. Well, I know a 10's up here. That negative 2 squared, right? And so that's just going to give me a 4. And so what number goes here? Is it positive or negative? Positive, so I put a plus 40. Y'all see that? Okay. All right. What are the letters?
Wait, where did you get 40?
4 times 10. The 4 came from negative 2 squared.
Oh.
Okay? So now, what are the letters here? X to the 6th, y cubed. And you want to think of, what are your numbers? So there's a 10, and then I have negative 2 cubed, which gives me a negative 8. And so what goes here? Negative 80. What are the letters? X cubed, y to the 4th. And now we need to think of what are the numbers? Well, there's a 5, and the negative 2 to the 4th gives you 16. And so what goes here? 80, but it's positive. And we do our last one. What are the letters? Y to the 5th. And then, what's negative 2 to the 5th? Negative 32. So I end up with a minus 32. These are tedious. All right? So, I've got 2 minutes, so I want to make sure I give your homework assignment. I don't know why I printed copies, because I thought you had time in class. We're not going to have time in class. In OneNote, it's still in the same chapter with the sequences and series. It's due Monday. It's called the Binomial Theorem. I only want you to do problems 11, 13, and 15. 3 problems, but they take a bit.
So, are you giving us copies or are we doing it?
It's in OneNote. I mean, I guess if you want a paper copy, you can grab one on the way out. Because we'll have to do it. If you want a paper copy, you can grab one on the way out. But, all right. So, all right. All right. Interesting patterns that I will explain why when most of y'all are back from not taking your AP World History test. Okay. Here is an interesting one interesting pattern. Okay, what's 11 to the 0 power? 1. What's 11 to the first power? 11. What's 11 squared? 121. Guess what 11 cubed is?
1,330. Whoa.
Wait, oh.
Guess what 11 to the 4th is?
I'm gonna guess 1,444.
Wait, oh, 6.
Wait, so instead of doing all that, we could just write like 11 or whatever?
You'd have problems to 11 to the 5th, but that's one interesting pattern that I'll explain why. Okay. Okay, if you add up the digits, if you add up this, you get a 1. You add up this, you get a 2. You add up this, you get a 4. You add up this, you get an 8. You add up this, you get a 16. Guess what happens if you add up the next row? 32.
45.
I'm sorry.